Alright, hi everyone, welcome to my YouTube channel, City of Electrons. So in this video, we are going to work or get the solution to this example using the Picards method. Of course, we talked about the Picards method in the last video. So we got the formula or the equation we use for it, and then we are going to apply it in this video. So using Picards method, find the solution for dy by dx equals 1 plus xy up to the third approximation. Recall that in our last video we said for first approximation, this is what you have. Second approximation, here becomes y2 of course. The rest things remain the same except this guy becomes y1. Now we are given the condition here that y0 equals 0. This is not just y0. Okay, this is the initial value of y. So the initial value of y is 0. Even x, the initial value of x is 0. Okay, so are we ready? Let's go. Now solution. Okay, so what we'll do now, this is what we have for our first approximation. y0 plus integral x0 x, and then we have x comma y. So this is a function of y and x, function that contains y and contains x. Of course, I just wrote down what we have from the last video. Okay, that's y0. Now, so for our first approximation, excuse me, let's just copy this to save time. Okay, so for our first approximation, y0 is 0, of course, is 0 given to us from the question. Look at it right here, y0 is 0. Okay, so here will be 0, and then of course what we have in here will be the differential equation. So what's our differential equation here? I mean, what's dy dx here? 1 plus xy. So that's what we are going to have here. So what we are going to have here is 1 plus xy. Okay, 1 plus xy. Now of course the initial value of y is 0 in this case, so we'll have 0 in this place. We'll have 0 here, so here will be 0, and clearly x multiplied by 0, that will give us 0 there. So I think I should just clean this whole part out if we understand that. So everything there will be 0, so 0, and of course 0 plus 1, everything will be 1. Okay, this will save our time. Beautiful. And of course if we have just 1 there, 1 multiplied by dx, of course 1 multiplied by dx is what? Just dx. So that's what we're going to have here, just dx. Okay, then if you differentiate dx with respect to x, of course what you are going to have is, this is y1 equals, of course this 0 is out, so integral of why am I saying differentiating, Jesus? If we integrate dx with respect to x, we are going to have what? X, of course, from lower limit to higher limit. And we've already seen that, of course, this will be x minus x0, but x0 there is 0, so we're going to have it as x. That means our y1 equals x. This is the first approximation. Okay, now for second approximation, the same thing. However, where we had x0, where we had y at y0, we are going to have y1 there, just like this. Look at it here. Second approximation, this part where we had y0, we're going to have y1 there. Okay, so let's pick this second approximation. Alright, so for second approximation we are going to have our y0, paste it here again. So for second approximation, y0, of course this is 0, this is y0, y0 is 0. Then our differential equation, of course, is 1 plus x y. We've already seen that this y1, which is this place now, y1 now, this one is what? X. y1 is x. So that means we are going to have x there. Okay, we are going to have, instead of y, we are going to have x here. So x, and of course x multiplied by x, that's x squared. So I just take this out and put the square here, x squared. So we differentiate this and we integrate this. So this will now give us y2 equals, this is 0 of course, plus, oh I think I should make it 0 already, 0. So I actually don't need this part again. So if we integrate this, we are going to have x plus x cubed over 3. This for second approximation. Okay, then for third approximation, we will have this. Here will be 2. Here will be 2. Here will be 3. That's indicating third approximation. And then here will be what? Here will be 2. Okay. So in our equation, dy dx hope you are following. Good. So this will be 1 plus xy. Okay, now y, of course y2. Okay, but y2 now, y2 is all this, so we are going to pack all this and take them into where we have y2. So I think we're going to have, let me expand this, expand that. So we are going to have 1 plus x. Y, to put y now, yeah, it's going to be all this. Good. Dx, correct. Okay, so we are progressing, and this is the last approximation. Okay, we are doing well. So here is 0 of course, and then we want to open the brackets first before any other yada, plus this will give us x squared, and this will give us x raised to the power 4 over that. So that will now be x squared plus x raised to the power 4 x cubed. Okay, so we just differentiate this, and that will be our third approximation. This will be x plus x cubed over 3, and then x is power 5 all over 15. That's it. Okay, that's it. So this is the third approximation. Okay, so in case we had something like look for y to the third approximation and then substitute in x at so value, we would have done that here. Okay, just like in Euler's method, we are giving a value for x to look for the approximate value of y when x is this, but these are the initial values. So we can also have that kind of questions like that. We have questions like that in Picards. So although this particular one just says we should look for the third approximation of y, which we have done. Okay, which we have done. So this is the third approximation for y, and we are done with this question. Okay, so yeah, share, like, comment, subscribe, click on notification bell, and yeah, this is all for this video. Thanks for watching, and I'll see you in the next video. Bye for now.